Welcome to Study Loop.
In this question, we are given a three-step process from state 1 to state 2. The gas undergo an adiabatic expansion from T1 equals to 588 Kelvin to T2 equals to 389 Kelvin. Okay, note that the gas is 1 mole of monoatomic gas. Okay, and then from state 2 to state 3, the gas undergoes an isobaric compression from T2 to T3, and then from state 3 to state 1, it is an isochoric process, and then the gas returns to P1 and T1. Okay, so in this question, there are 4 parts. In part A, we need to plot a PV diagram for these processes, and then part B, we need to find T3, part C, we need to find delta E internal and WQ for each process, and also for the whole cycle in part D. Okay, so for part A, okay, to plot the PV diagram properly, there are a few things we need to use. Okay, so certainly the equations that we will be using. So the ideal gas equation, PV equals to nRT. We can find V1. Okay, so V1 equals to nRT1 divided by P1. P1 is 1 atmospheric pressure, so we have 1 mole 8.314 times 588, okay, divided by 1 atmospheric pressure in Pascal, 1.013 times 10 to the 5, and you calculate the volume. V1 is 0.0483 meter cube. Okay, and then during the adiabatic expansion, okay, be using T1 V1 to the gamma minus 1 is equal to T2 V2 to the gamma minus 1. Okay. Yeah, because we have T1, we have T2, we also have V1, and using this equation we can find V2. Okay, so V2 is equal to T1 over T2 1 over to the power 1 over gamma minus 1, and then times V1. Okay, so gamma equals to 5 over 3 for monoatomic gas. Okay, so you have T1 is 588, then T2 is 389, and then 1 over gamma minus 1, you get 3 over 2, and then V1 0.0483, calculate this, you get 0.0897 meter cube. Okay, and then we can also find P2. Okay, so using P1 V1 to the gamma is equal to P2 V2 to the gamma. Okay, so P2 will just be P1 V1 over V2 to the gamma. Okay, so put in the numbers. Gamma is 5 over 3, and then you get 3.61 times 10 to the 4 Pascal. Okay, so and also we know that V3 equals to V1, okay, because isochoric process. Okay, so now we are ready to plot the PV diagram. Okay, so V1, V2. Okay, so this is 0.0483, 0.0897. And then we also have our P1 and P2. Okay, so it will look something like this. Okay, and then this is P pressure in Pascal, and P1 is 1 atmospheric pressure, so this is 1.013 times 10 to the 5, and then P2 is 3.61 times 10 to the 4. Okay. Okay, so with this diagram, PV diagram, we can proceed to find T3 in part B. Okay. Okay, so just now we have T1 V1 to the gamma minus 1 is equal to T2 V2 to the gamma minus 1, right? And we also have V1 equals to V3. Okay, so and from isobaric process, so pressure is constant. Okay, so V2 over T2 is equal to V3 over T3. Okay, so that means and since V3 is V1, so it's V1 over T3 as well. Okay, so we have V2 over okay, so from here we have V1 over V2 to be equal to T3 over T2. Okay, and then we also have V1 over V2 to the gamma minus 1 is equal to T2 over T1. So this means that T3 over T2 to the gamma minus 1 is equal to T2 over T1. Okay, and then T3 is equal to T2 over T1, 1 over gamma minus 1 times T2. Okay, you substitute the numbers. T2 is 389, T1 is 588, then gamma is 5 over 3, and you get 3 over 2 over here, and you multiply by T2, 389, and you get 209 Kelvin. Okay, so this is the answer for T3. Okay, now in part C, we need to find the change in internal energy, the work done by the gas, and the heat added to the gas for each process. Okay, so in this question, we are using the first law of thermodynamics. Okay, so which says that delta E internal equals to Q minus W. Okay, and then we note that for adiabatic process, Q equals to 0, right? And then for isochoric process, W equals to 0, okay? And then for monatomic gas, A delta E internal is equal to 3 over 2 and R delta T. Okay. Okay, so for process 1 to 2, okay, so this is adiabatic process, adiabatic expansion. Okay, so we know that Q equals to 0 immediately, and then delta E internal is equal to 3 over 2 and R delta T. So this is equal to 3 over 2, 1 mole times 8.314 times T2 minus T1. So T2 is 389 minus 588, and you calculate this, you get negative 2480 joules. Okay, and then first law says that delta E internal is equal to minus W. So W is equal to minus delta E internal, you get 2480 joules. Okay, so this is 1 to 2, and you have Q equals to 0, and then this is delta E internal, and then this is W. Okay. Okay, next we have 2 to 3, process 2 to 3. Okay, we have isobaric, compression. Okay, so this means that you can find delta E internal first, since we have the temperatures. Okay, so 3 over 2 times 1 times 8.314 times T3 minus T2. T3 is 209, then T2 is 389. And you calculate this, you get negative 2240 joule. Okay, and then the work done by gas is P delta V. Okay, so P2 is 3.61 times 10 to the 4, and then delta V is V3 minus V2. So you have 0.0483 minus 0.0897, and you calculate this, you get negative 1490 joules. Okay, so from first law of thermodynamics, okay, so Q is equal to delta E internal plus W. Okay, so you have minus 2240 minus 1490, and you get negative 3730 joules. Okay, so this is the delta E internal, this is the W, the work done by gas, and then this is the Q. Okay, so one thing to note is that if you are given the initial and final temperatures, you can always calculate the delta E internal first. Okay. Okay, then lastly we have process 3 to 1. Okay, so we have isochoric process. So in this case, we know that W is equal to 0, okay, because there's no change in volume, and delta E internal is equal to Q is also equal to 3 over 2 and R delta T, okay, 3 over 2 times 1 times 8.314. The delta T is 588 minus 209. When you calculate this, you get 4720 joules, okay? Right, so I'm going to summarize them into a table, because once we summarize in a table, we can do part D easily. So we have process, delta E internal in joules, Q in joules, W in joules, okay? So we have 1 to 2, 2 to 3, 3 to 1. Okay, so minus 2480. Here we have 0. Here we have 2480. Okay, and then 2 to 3 we have negative 2240, negative 3730, negative 1490. Okay, and then for 3 to 1, delta E internal is 4720 and Q is 4720. Okay, and then W is 0. Okay, then in part D, okay, for the whole cycle, okay, cycle, okay, we just follow through the table. Delta E internal is 0, Q is 990 joules, W is 990 joules. Okay, okay, you just sum the numbers in the table, and this is what you get. Okay. All right, so that's all for this question.